Start recording. Testing, testing. Michael Wickerson here. Basically, I am playing with some old grade 12 or senior mathematics in high school. For some, sometimes it's a little earlier, junior year. What I have going here is a kind of reciprocating sine engine that will just run some numbers between -1 and 1 so I can get some articulation. And then I've generated very simple mesh geometry that's kind of this weird mechanism clock, which I thought people might find interesting. And I am using Visual Studio Code, so if I grab this and bring this over, you'll see that all my code is popping into Visual Studio. So I'm using GitHub Copilot to write it. It's not difficult script, but I think it's nice to kind of check that script with Visual Studio. But even though that's live on certain ones here, I'm just going to ungroup, and basically have all of these working. So I've got a nice little mesh that's basically playing off of each one of these algorithms. So what I'll probably do is take this to preview off and then have each one of these preview on, and then just set it so I can see what's clicking. So the first one's pretty simple. This geometry isn't too hard. It's actually kind of hard to see with what's going on there. Let me get all my lines out. Actually, maybe I'll let this one, yeah, I guess I should just keep it simple. What do I have going on here? All these lines compared to these lines. I'm just basically using a little bit of the complementary angle theorem to play off. Well, I see why there's nothing there because my gauge is set so small. You can see that basically I have a right angle that I've generated, and then I'm just oscillating the bisection of that to show that no matter what two angles appear in these corners, they should equal 90 degrees. And I was doing that up here actually before, because this is a deductive geometry node that I actually am piping. But let me just take this preference to something a little more visual. There's the purple, and when I'm selecting it. So I basically went in and wrote from, just to get this figured out a little simpler, just went into with the connection to Visual Studio Code using GitHub Copilot. You can just type in algorithms, Euclidean geometries, similarities, transformations, deductive geometry, and then write an algorithm that demonstrates the complementary angle theorem. And it basically generated that for me, which was pretty nice. And then I did have, if the angles got close to 90 degrees, whether the two angles would equal 90 degrees or not, no matter what. And the angles were being calculated between here and here. So I've just got it on turntable rotation, so it looks a little interesting to look at. And then the next one was the supplementary angle theorem. So if I jump down here and grab this one, it's dealing with a circle and basically taking a straight line saying that these two angles will equal 180, or two right angles. And so if I open that one up, you'd see that that script was generated once again from GitHub Copilot. Not too difficult. You can just type in your comments, write an algorithm that demonstrates the supplementary angle theorem, generates it, puts its outputs in, and you're done. So pretty simple. And then I did the vertically, I don't know if it's spelled vertically right, vertically opposite angle theorem. At least that's how I spelt it back about 35 years ago in school. And you can see that that is just taking the vertical opposite angle theorem. These two angles will always be the same no matter what's happening. And so I just kind of put these all in to different I controlled the script enough to make them not coincident, so I just rotated the planes around each time, and maybe I altered these numbers. But once again, the script ran, and I was able to get my outputs, my circles, my lines at 45 degrees and 225 degrees, and then a random line in between is just generated. Sometimes I add a little bit of jazz up here first just to make it interesting. But the last one I did, actually the jazz would be here, but I've got it going through that oscillation. And these scripts I'll have online. I'm just going to process through, do the corollaries of the ASTT, getting down to the exterior angle theorem, and then I'll go into isosceles triangle theorem and parallel lines theorems, and just keep making these models. The last one was angle sum triangle theorem, and those are the corollaries I'll play off of. So I put that one down on here. So it basically just keeps generating triangles to prove that the interior angles are 180 degrees. You can write the logic in to check that, and then I've also got a little bit of control, parametric control, to change that triangle as it oscillates, depending on how I want to do it. So pretty simple. I'm just keeping them all at 1 for now, so they're all, actually I'll probably put that 1. Doesn't matter where I put it because the oscillation is going to be a multiplier to it. But that script was the same type of thing. Put it in here, and that's the one that actually recently I sent over to Visual Studio Code. So there's the script being generated. It updates, and then it pops in here, and then my C script is generated. So all together, if I take the whole kit and caboodle, take all those and put them to preview off and put this one on. We can click it and you'll see this wonderful model. It's kind of like this weird mechanism clock that's calculating everything as we go. And I think what I'll do is pull that one back up to, pull that back up to here, and probably, actually we'll just do the lines for now, but if I can get this, oops, every time you click a slider, pull that one back up to 10, and then we'll be able to see here. There you go. You get the triangle on the 45-degree plane. You've got it on the XYZ planes. A nice little mechanism. And that's it. Something to start with. Build yourself a nice little model, oscillate through it, and you can come to understand. And then if you wanted to go so far as to bake some geometry as you go, I'm going to probably just take this off because it'll go a little slower. But if I wanted to actually bake this geometry as I play, I can just hold down the button. You'll see that you start to generate some really cool geometry patterns as you go. So models that kind of make models out of themselves. So I find that's an interesting tool to just produce your own geometries. So hopefully you find that interesting. I'm going to stop streaming and I'm going to continue with this, just like I said, like junior, senior level high school math, but applied to Rhino and Grasshopper. And then if I don't know why my script's so big down here. It's basically playing off the C Parasite node, which is there. And then if I actually wanted to, I can't see the C Parasite node, but I do have a little side node here that was generated. That was a nice tool using the Grasshopper document doc, so a Grasshopper doc API to script in a little something so that would be automatic. And those are things you can learn through Parametric Camp. But otherwise, that's pretty much the gist of it. I hope you enjoyed it, and thanks very much for watching. Stop streaming and stop recording.